Right, so we want to graph this logarithmic function. We're being, let's see, we're being asked to graph y equals the logarithm of x minus 1 base 1/5 minus 5. Well, oftentimes in order to graph this, in order to see what this looks like, it might be best to focus just on this at first, the logarithm of x base 1/5. If I can graph this function, then the minus 1 and the minus 5 would just be the appropriate transformations, vertical and horizontal shifts. So to graph a logarithmic function like this, we can actually focus on the inverse of this function first. The inverse of a the inverse of a logarithmic function is an exponential function. The inverse of this function would be y equals 1/5 to the x power. And so what I'm going to do is I'm going to find some points with the equation y equals 1/5 to the x, and then I'll invert them, and that'll give me my points for my other function, the one that I want to graph. All right, so here's an xy table that I'm going to keep track of points for the equation y equals logarithm of x base 1/5, and I'm going to have another table for this exponential function over here. If I put 0 in for x, it looks like I'll get 1, because y equals 1/5 to the 0 would be 1. If I plug 1 in for x, I would get 1/5. Y equals 1/5 to the 1 would be 1/5. If I plug 2 in, 1/5 squared would be 1 over 25. And I'm going to put in some negative numbers. If I insert -1, that would cause the 1/5 to flip, so it would be 5. And -2 would end up being 25. That would be 1 over 5 to the -2, which is 5 over 1 to the +2, and so there's where the 25 comes from. All right, now what we do is we flip all these points around. So instead of 0, 1, we're going to have 1, 0, because that was the inverse. We basically just use the exponential function as a tool in order to get some points. It's easier to plug numbers into the exponential equation than it is the logarithmic equation. So I'm flipping all the order pairs around, I'm inverting them, I'm interchanging the x and the y. And I have 25, -2. Now we're going to graph these points. When we have a logarithmic function, all logarithmic functions have a vertical asymptote. And by default, the logarithmic function will have a vertical asymptote at x equals 0. It'll be right on top of the y-axis, as long as there's no transformations. So the vertical asymptote of this function, log x base 1/5, is going to be right on top of the y-axis. So I put a dashed line on top of that y-axis, and we have 1, 0. 1/5, 1 is kind of hard to graph. If x is 1/5, we get 1. Let's see, so that'd be, it's hard to 1/5, and then 1 would be like up here. Oops. So small, it's hard to sketch. I'm not even going to try to graph 1/5. 2. 5, -1 would be here. 25, -2. That 25, -2 is off the coordinate plane and be like, about right here, I guess. And so this function would go like this. We don't really have to go all the way out to the 25, -2, I suppose. When graphing this in my math lab, notice that it says it wants 2 points. on the coordinate plane here I have 3, and then that point right there is actually a 4, so you don't need this many points. This logarithmic function would hug the asymptote, right? It would hug the y-axis. It'd get closer and closer to it. Right, now we just graphed y equals log x base 1/5, but of course we actually want y, we actually want this function up here, y equals log x minus 1 base 1/5 minus 5. Well, the minus 1 on the inside, that shifts the graph to the right 1 unit. If we think back to the horizontal and vertical transformations, since there's a minus 1 on the inside, that shifts the graph to the right 1 unit. If it were a plus 1, it would shift it left. And then the minus 5 on the end shifts it down. So the function that we want is going to be the same as the function that I just did in green, except it's going to be to the right 1 unit, and it'll be down 5 units. So let's try this. So it's going to be to the right 1 unit and down 5 units. So it's to the right 1 unit. So the vertical asymptote is going to be at x equals 1, this purple line. Whenever we have a logarithmic function, the vertical asymptote will always be it'll always be a vertical asymptote. And so that's actually one of the things they wanted me to find, was the equation of the vertical asymptote. The equation of the asymptote, the equation of the vertical asymptote is x equals 1. That's the equation of the purple line. They also want me to find the domain. All right, so basically our points are just shifting, so like instead of 5, negative 1, we want to go to the right 1 and down 5. So instead of 5, negative 1, let's see, I'm going to go to the right 1 and then down 5. 1, 2, 3, 4. So it looks like that point would be right there. So again, I started at 5, negative 1, and I went right 1 and down 5. So here, I'll keep track of the new points. So that new point looks like it'd be what, 6. If I go to the right 1, it'd be at 6, and then down 5. So 6, negative 6. We just need 2 points according to my math. That's all I want. One of the other easy. So I use 5, negative 1 is probably an easier point to use, and probably the other easy point to use would be the 1, 0. So instead of 1, 0, if I go to the right 1 and then down 5, it'd be right there. Looks like it'd be at 2, negative 5. Again, that's all we need is the 2 points. But if we wanted to do another one, let's see. Instead of 1/5 1, if I go to the right 1, it'd be at 1 1/5, and then down 5. So 1, 2, 3, 4, 5, about right there. Oops. So this graph, what I'm drawing now in purple, is the actual answer that we would put in my math lab. The graph in purple. The graph in purple is supposed to be the same thing as the graph in green, just to the right 1 and down 5. So the graph in purple is what I would put in my math lab. And it looks like the domain is 1 to infinity. Right, the domain is the x coordinates. So the domain always starts where the vertical asymptote is at x equals 1, and then you can see the graph goes to the right. So it's 1 to infinity.